Welcome to EDU World Space.
In this question, we want to evaluate the triple integral over e of e to the power of z over y dv, where e is the set of points x, y, z, such that y is between 0 and 1, x is between y and 1, and z is between x and y. So let's set this up. We have the triple integral of e to the power of z over y. I'm going to integrate with respect to z first, integrating from 0 to xy. Then I integrate with respect to x. X's go from y to 1. And then finally I integrate with respect to y. Y's go 0 to 1. So first I need my antiderivative of e to the power of z over y with respect to z. So integral 0 to 1 of the integral from y to 1. My integral of e to the power of z over y is e to the power of z over y. Now, I'm not quite done. For example, if I had an antiderivative of e to the 3x dx, what would that be? It would be e to the 3x over 3. So I would rewrite that exponential and then divide by the coefficient on x. So here, I rewrite my exponential and I divide by the coefficient on z. The coefficient on z is 1 over y. And then this is going to get evaluated from 0 to xy dx dy. So continuing to simplify, integral 0 to 1, integral y to 1. Division by 1 over y is multiplication by y. So ye to the z over y power, evaluate 0 to xy dx dy. I plug in my top limit of integration first, which is xy. So integral 0 to 1, integral y to 1. When I plug in xy, I get ye to the power of xy over y, which is just x, minus ye to the 0 power, which is just y. All of this dx dy. Now we get our antiderivative with respect to x. So what's that? It's going to be ye to the x minus yx. We're evaluating on the interval from y to 1, and then it's all of this dy. I start by plugging in my top limit of integration, 1. When I plug in 1, I get y times e minus y. From this, I subtract what I get when I plug in y, which will be ye to the y minus y squared. All of this dy. So if I distribute integral 0 to 1 of ey minus y minus ye to the y plus y squared dy. Now my antiderivative with respect to y, the tricky one is this third term. So if I want an antiderivative of ye to the y, I'm going to use integration by parts. So I'm going to let u equal y, my dv be e to the y dy. My du will be dy, my v is e to the y. So my integration by parts formula, right, u dv, you get ye to the y minus the integral of v du minus the integral of e to the y dy. So you've got ye to the y minus e to the y. So what's my antiderivative? I've got e times y squared over 2 minus y squared over 2 minus ye to the y minus e to the y plus y cubed over 3. And all of this is going to get evaluated 0 to 1. I plug in the 1. I'm getting e over 2 minus a half minus. Now you get e to the first minus e to the first, so you get 0 plus 1/3. From this, I subtract what I get when I plug in 0. That would be 0 minus 0 minus. Now in the parentheses, you actually get 0 minus 1, so you get -1 plus 0. So let's see, I'm getting e over 2. Negative a half plus a third is -1/6. And then it's here you've got a positive 1, but you're subtracting 1. So that I have e over 2 minus 7/6. And that'll be my final answer for the question. Hopefully that's helpful and makes sense. Have a good rest of your day.